Hello students, I am Sachitrakash. Welcome to Cars Physics. We are continuing chapter number 2, electric potential and capacitance, and this is my lecture number 23 on the chapter. Okay. So in lecture number 22, we have discussed some fundamental numericals on combination of capacitors. Okay. And I have told you lecture number 22 is part 1 of the numericals based on combination of capacitors, and again I have discussed that we will raise the level of numericals gradually. Okay, we will raise the level of numericals gradually. In lecture 22 means in part 1 of the discussion, I have discussed very easy numericals and basic numericals. Okay, so there are some concepts which should be applied while solving the numericals on combination of capacitors. Okay. So charge division method, potential method, Kirchhoff's law and Wheatstone's principle of balanced Wheatstone's bridge, those principles how to apply. And in this lecture, means in part 2 of numericals on combination of capacitors, I will discuss the numericals based on connecting wire of zero resistance. Connecting wire of zero resistance. Okay, we will apply this connecting wire of zero resistance while solving the numericals. Okay, then resistance. We will discuss, we will have complete discussion on resistance and all these things related to electrodynamics in brief. But in this lecture, we should have very basic idea about resistance. Resist means oppose. So resistance is the property of a conductor. Resistance is the property of a conductor due to which it opposes the flow of charge through it. Okay. If we consider resistance of a conductor has some resistance. Then when charge is transferred through the conductor, then work is done against the opposing force. Then to do work, energy is required. So if work is done, then work done is equal to potential difference into charge, product of potential difference and charge. Okay. So if work is done, then potential decreases. Work is equal to potential difference into charge. If work is done against opposing force, then there is a decrease in energy, means there is a decrease in potential. Okay. If we consider resistance, then if charge flows through it, there will be potential difference between any 2 points of the conductor. If charge is flowing, then work is done. Then if you consider this is a point, this is a point, then if charge flows through it, then potential decreases. Means we will have potential difference between these 2 points. But if we consider there is no resistance and charge flows through it, there is no opposition. So we will have no change in energy. So there will be no decrease in potential. Potential will remain same because there is no expense of energy. This is the concept. Okay. So we will use this concept. Say if 2 points, another basic thing, if 2 points are connected by a conducting wire of zero resistance, then from the beginning of the experiment, suppose 2 points are taken, means 2 ends of a conductor you may take, 2 points are maintained at different potentials. A switch is there. If you make on the switch, then charge will flow from high potential to low potential till potential becomes same. This is our principle. Then if charge flows and if there is resistance, there will be opposition and there will be decrease in potential. Means If 2 points are connected by the help of a conducting wire of zero resistance, then there will be no work, no decrease in potential. Potential will not decrease. Okay. So potential will constant. 2 points are joined by a conducting wire, then potential of 2 points is same. This is the principle. Okay. See, number 1, number 2, number 3. Let's consider 3 capacitors, C1, C2, C3, and all of these have same value, let 0.2 microfarad, connected to points A and B. Potential of A is V, potential of B is 0. Then obviously these 3 capacitors are joined in series. Okay. These 3 capacitors are joined in series. But here, see, I am connecting a wire from C to D. I am connecting a conducting wire of zero resistance from C to D, connected between C and D. Then another conducting wire, let this point is E, this point is F. Another wire is connected between 2 points E and F. Is it clear? Then, how to know? C1, C2, C3 are connected in series or in parallel. So we have considered conducting wires. We have considered conducting wires of zero resistance. See, if potential of point A is V, obviously potential of point C is V, because there is no obstruction. Resistance or resistor or capacitor, there is nothing between A and C, means there is no obstruction, so there is no decrease in potential. If potential of A is V, then potential of C is V, and also potential of D is V, because point C is connected to point D by the help of a connecting wire of zero resistance. So these 2 points are also at same potential. Okay. So potential of this plate is V, because this plate is connected to C. So potential of this plate, C, potential of point F is 0, because it is connected to point B. Point B, let us be 0 potential. So potential of F is 0, and similarly potential of E is 0, since F and E are connected by the help of a connecting wire of zero resistance. So potential is same. So potential of this plate is 0, because this plate is connected to 0 potential, which E, point E. And if this potential is V, then potential of this plate is V, because there is no obstruction. Just it's a connecting wire of zero resistance. So potential is same. Again, potential of this plate is also equals to potential at D. Again, this plate is connected to zero potential, so this is at zero potential. Now see, this plate, and this plate, three plates are at same potential V. Number 1, number 2, number 3. Then all these plates, 1, 2, 3, are at potential V. Then we may connect all these 3 plates to a common point, potential V. Then potential is V. Okay. Then second plate, see, potential of this plate is 0. It is connected to 0 potential. Okay. Potential of this plate is 0. It is connected to 0 potential. Potential of this plate is 0. Then 1, 2, 3. These 3 plates are connected to 0 potential. 1, 2, 3. Connected to 0 potential, means this point is A, this point is B. Okay. Then this capacitance is C1, this is C2, this is C3, connected to terminals V and 0. Potentials are V and 0. Then this is the case of parallel grouping of capacitors, potential 0, 0, 0. So potential difference V, V, V. Okay. So charge gets divided, whatever charge we may take conventionally from positive to negative. Okay. High potential to low potential. So obviously all these capacitors are in parallel. You know This is the parallel combination. First plates are connected to a common point, second plates are connected to a common point. Two common points are maintained at different potentials. Okay. Then here total capacitance, equivalent capacitance is C1 plus C2 plus C3, and here value of all capacitors is same, and that's equals to C by 3. Sorry, 3C. C plus C plus C is equal to 3C. Then our answer is 3 into 0.2, 3 into 0.2, that's equals to 0.6 microfarad. 0.6 microfarad. Okay. So first take it in your mind that how to connect the plates and to know the potential, then all the numericals will be easier for you where there is connecting wires of zero resistance. Okay. Then second one, see, this is a combination. This point is A, number 1, number 2, number 3, number 4, number 5, and finally connected to B, which is at zero potential, and point A is at potential V. Point B is at zero potential and point A is at potential V. Okay. Let this capacitance is C, this is C, this is C, this is C, and this is also C. Now you will use connecting wires of zero resistance. See, first wire, let this point is D. This point is D. Point D is connected to point, let it is E. Let it is E. Okay. Then another conducting wire. Okay. Another conducting wire, let us start from F. Let us start from F. Connected to this point, let this point is at G. Okay. Another conducting wire is connected between F and G. Then another conducting wire from G to, let this point is H. Okay. So these are conducting wires. C. Now we will divide the potential C, V. Point A is at potential V. So this plate of first capacitor is also at potential V, because this plate is connected to point D and potential of D is V, since D is connected to A. Okay. Then potential of point E is also V, because D is connected to E. So potential of this plate is V. This is V, this plate is connected, this is V. Okay. Then let this potential is V1. Work is done. So potential becomes V to V1. So potential of this plate is V1. Okay. Potential of this plate is V1, because this plate is connected to point F. Okay. Again, potential of this plate is this plate is connected to F. Potential of F is V1. So potential of this plate is V1. Okay. Again, this potential is V. So potential of this plate is V. Potential of this plate is also V. But see, so if this is V, then this is also V. See, this potential is V1. Point F is at potential V1. F is connected to G. So G is at potential V1. Point F is connected to point G. Potential of F is V1. So potential of G is V1. So potential of this plate is V1. Okay. Then again, this plate is connected to point G. Then potential of this plate is V1. Potential of this plate is V1. Okay. Then potential of this plate, see, G and H are connected. If potential of G is V1, then potential of H is V1. Potential of G is V1. Potential of H is V1. So obviously potential of this plate is V1. Potential of this plate is V1. And this plate is at zero potential. The previous concept is applied. Now see, V, V. V, this is V, this is V, this is V. So, all these three plates are at same potential. Now we can connect the plates to a common point where potential is V. Let this is the point at potential V. So, this is the plate, potential is V. This is the plate, potential is V. This is the plate, potential is V. 1, 2, 3. 1, 1, 2, 3. V, V, V. So since potential of all these plates are same, they may connected to a common point which is also at potential V. Means potential of this plate is equal to potential of all the first plates. Okay. Then V1. V1. This plate is at potential V1. 1. This plate is at potential V1. 2. This plate is at potential V1. 3. Then these three plates at potential V1, V1 and V1 are at same potential, so connected to another common point where there is potential V1. Okay. So 1, 2, 3. 1, 2, 3. We have completed up to this. Then this capacitor. 1, 2, 3. Okay. Then potential of this plate is V1. This plate is also potential of this plate is V1. Potential of this plate is also V1. Means potential difference is 0. Okay. Potential difference is 0. Means this capacitor will not be taken into account because here there is no potential difference, means no energy is stored. Okay. So, the potential of two plates same, then it is called as short-circuited capacitors. Okay. We will discuss about that in some other part of the discussion on numericals. Okay. Then potential of this plate is V1. Let's take this plate. Potential is at V1. Then this plate is at 0 potential. And finally, we reach that point B and we reach that point A. Okay. Since all the capacitors have same capacitance, 1, 2, 3, 4, 5. VV1, 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 V1, V1, 0. Okay. This is not taken into account and this is V1 and 0. Okay. Then we may make equivalent circuit. C, C, C in parallel. Total capacitance is 3C and this is of capacitance C, C. Then finally, this point is B, this point is A, and finally, this point is A. Total potential 3C and C in series. Okay. Then total capacitance is 3C into C divided by 3C plus C. That's equals to C equivalent capacitance. It is equals to 3 by 4C. Okay. 3 by 4C. This is the answer. Okay. Then now we will approach some 1 or 2 numericals based on same principle, but something different. Something different. Okay. See. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Let's take another one. 6. Let's take another one. 7. Okay. Whatever number you may take, whatever number. See, suppose I am connecting wire like this. Number 1. Okay. this is number 2, this is number 3. Number 1, number 2, number 3. There are 3 connections. Again take C, 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 C. Okay. It will be easier. This point is at potential V. This point is at potential 0. C. This is V. This potential is V. Okay. This potential is 0. This potential is 0. Then let this potential is V1. Then this potential is also at V, because this is V, this is V. Okay. Then this potential V1, so potential of this point is V1. So this point is also at potential V1. Okay. Then now see V, V1, V1, V. This is V, this is V1, 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 V, V. Okay. This is V1. Okay. This is V1. So this is also V1. Okay, okay. The similar problem comes. See, the final 2 points, these are the final 2 points, are at same potential V1 and V1. So all these capacitors are not taken into account, because the final ends are at same potential, so these capacitors are not taken into account. Okay. Potential difference is 0. Okay. Then now potential of this plate is V. Potential of this plate is V. Potential of this plate is V. Okay. Then all these plates are connected to a common point. Common point. And potential V1, V1, V1. Potential V1, V1 and V1. Okay. So all these are connected to a common point. V1, V1, V1. All these are connected to a common point. Okay. Then these 3 are not taken into account. This potential is V1. So obviously this potential is V1, because this potential is at V1 and this is potential at 0. So potential of this point is V1, potential of this point is V, and here another capacitor, this capacitor, potential is V1 and final potential is 0. This is the combination. Okay. Then capacitances are same, C, 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 and this is also C. Then these 3 are in parallel. Then equivalent capacitance is 3C. This capacitance is C. Now both are in series. Then the answer will be same. 3C into C divided by 3C plus C, and it is 3 by 4C. Again the same type of problem, numerical. Okay. Okay. This is repeated one. Okay. Something different means capacitors are more. Then another numerical. You will learn from it, and very good numerical. So connecting wires, see. I am taking some capacitors, number 1, number 2, number 3, number 4, number 5. Okay. Let capacitance of this capacitor is 12 microfarad, this is 10 microfarad, this is 5 microfarad, this is 9 microfarad, and this is 8 microfarad. So we have used 5 capacitors, 12, 10, 5, 9, 8 microfarad. Now we will use connecting wires of 0 resistance. Okay. This is a connecting wire, 1, 2. Okay. Okay. Then take another conducting wire from this point. Let's take from this point. Okay. Then this wire is connected to this point. Okay. Let this potential is V, this is V. Okay. This potential is V1, this is V1, this is V1. So this potential is equal to this potential. These 2 points are joined. So potential of this point is V1. Okay. Potential of this point, see. Okay. Potential of this plate is V1, and potential of this plate is, let V2. This is V1, this is V2. Okay. Then potential of this plate, we will take V2 because this is V2, this will be also V2. Okay. So potential of this plate is V2. Okay, then this point is connected to this point. So these two are same potential. Potential of this plate is V1. Potential of this plate is V1. Okay, this is V2. This point is at V2. So this potential is V2. So potential of this plate is V2, and potential of this plate is V2, and potential of final plate is 0. Just apply the same principle. Just apply the same principle. See, V, only V. There is no such plate which has potential V, the only plate. Okay. This potential is V, this potential is V1, first capacitor. Then this potential is V1, this potential is V1, this potential is V1. 1, 2, 3. V1, V1, V1. So all these plates are at same potential V1, V1, V1. Connect them to a common point. Okay. Again, potential of this plate is V1. We may join now. Common potential is V1. This is V1. This is V1. So all these plates are at potential V1. This is V2. This is V2. This is V2. Okay. V2, V2, V2. All these three plates are at same potential. Now join them to a common point. 1, 2, 3. Okay. Then final capacitor, first plate is at potential V2. Potential of this plate is V2. And this plate is at 0 potential C. Now we have arranged the capacitors in proper manner. Okay. Capacitance of this plate is 12 microfarad. This is 10 microfarad. This is 5 microfarad. This is 9 microfarad. And this is 8 microfarad. Then we have to calculate effective capacitance between these 2 points, or equivalent capacitance. Okay. See, this is first point. This is A. Let this is A. This is A. Okay. Then this is 12 microfarad. All these are in parallel. C1 plus C2 plus C3. 10 plus 5. 10 plus 5 plus 9. Then it is 24. 24 microfarad. C1 plus C2 plus C3. So equivalent capacitance in parallel. C1 plus C2 plus C3. 10 plus 5, 15. 15 plus 9, 24. Okay. Then final capacitor, this one. This one has capacitance 8 microfarad, and this point is B. Okay. Then all these three capacitors are now in series. Okay. Now in series, second plate, first plate, second plate, first plate, our common discussion. Okay. Then equivalent capacitance is equal to 1 by C1, 1 by 12 microfarad, 1 by C2, 24, 1 by C3, 8. Now we will solve for it. So, C equivalent solving, you will get reciprocal of equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is our basic formula. Then solving it, you will get 4 means 4 microfarad. Okay. So these are some numericals on the basis of connecting wires of zero resistance. Okay. But always keep in mind how to divide the potential. How to divide the potential. Okay. In lecture number 24, means in part 3, on the numericals of combination of capacitors, I will discuss some very important numericals which are seriously applicable for competitive exams like NEET and JEE. So next lecture is very important. Okay. See you again. Thanks.